This is a quick video lesson going over some of the things we have been talking about in class dealing with proportional relationships. If you look at the top of this lesson, it talks about the summary and it says when two proportional quantities or amounts are graphed on a coordinate plane, the points will appear on a line and they pass through what we call the origin. And in class, we've talked about how the origin is the point 0, 0 on the graph. So let's go ahead and just look at a couple graphs and discuss why these may or may not be proportional relationships. So looking at graph 1A, it's really important that we take note of the title of the graph and also the titles of our X and our Y axes to really make sure we understand what we're talking about. So in this graph, we're talking about donated money versus the donations that would be matched by a benefactor. So along my x-axis here, I have 0, 100, 200, 300, 400, and 500, and that's the money I donate. And as I'm donating money, there are benefactors that are matching my donations. So if I donate $100 and I go up to my dot, that means that the benefactor matched $100. If I donated $200, the benefactor matched $200. $300, 300, and so on. And you can see we have this kind of staircase step going up. And what it's doing is going up in a very constant direction. In other words, it's not changing the rate of increase. It's staying the same. Another thing we notice is down here at the bottom of our graph at 0.00, or what we like to call our origin, we also have a point. Which makes sense because if I do not donate any money, I will not have a benefactor match my donation. So does this graph pass through the origin? Yes. Does it have a nice straight line going up consistently? Yes. So this is a proportional graph. Yes, proportional. Let's go ahead and take a look at B. So looking at B, we have age versus admission price. So a price to get into something. And along the x-axis here, we have the age going from 0 years of age up through 8 years of age. And if I go ahead and go start at 0 years of age, it costs $6 to get in. Well, if I'm 1, it costs 6. If I'm 2, it costs 6, and so on. So the first thing I want to ask myself is, okay, do I think this line will go through the origin? And clearly it will not. So that right there means I do not have a proportional relationship. Another thing to notice is this is a straight line, but we don't see any sort of increase or constant rate of change. So if we go back to A, we can see that this line is increasing at a consistent rate. Over here, it doesn't matter if you're 0, 3, 5, 8, or any age, you are always going to pay $6 admission. So because this does not go through the origin and does not have a constant rate, straight line increasing, this is not a proportional relationship according to the graph. The last graph we want to take a look at, we're talking about extra credit versus the number of problems a student would do. And if I go ahead and even just connect all of my dots here, kind of see what sort of line we're working with, you can see pretty quickly off the bat, we don't have this straight diagonal line with a consistent rate of change. For problems 0, 1, and 2, you're not getting any extra credit. So sure, we're down here at the origin at 0, 0. But we don't have this nice, straight, consistent line increasing at a constant rate like we did in graph A. So because of this slight swoop, this curve, the fact that these three have a different rate of change than these guys, this is also not proportional. So in summary, when looking at these graphs, in order for them to have a proportional relationship like this one, you need them to go through the origin and have a nice straight diagonal line that shows a constant rate of change. Now flipping onto the back of this paper, we are given a table and we want to put some of these values in our table.